we have taken so far different examples actually of electrophilic aromatic substitution reactions such as halogenation, nitration, sulfonation, and Friedel-Crafts alkylation. Let's now take another example of an electrophilic aromatic substitution, but this time we take acylation, how we can attach an acyl group to benzene in what would be called an acylation reaction. So let's again try to draw a scheme, a general scheme for the reaction. This is benzene. So in order to make acyl benzene, which is something like that, so probably you can expect that this acid chloride would be required, and of course, as usual, the Lewis acid catalyst. Now this reaction is acylation. It's called Friedel-Crafts acylation. It is acylation because an acyl group, this is an acyl group, gets bonded to benzene. Of course, the product is an aryl ketone. This is an aryl ketone, yeah? It's a phenyl ketone specifically. So how does this happen mechanistically? Now, if you look at the structure again of the Friedel-Crafts acylation, this ketone structure, probably you can identify the electrophile that's needed, which is this acyl cation. So this acyl cation is actually essential in this reaction. It should form upon reaction of this acid chloride with the Lewis acid catalyst. So that's what we should try to explain its formation. So we take now the acid chloride, that's the acid chloride, and then we try to react it with AlCl3, the Lewis acid catalyst. Remember, these chlorines, okay, act as Lewis bases. Of course, aluminum is the Lewis acidic center, if you like, in aluminum chloride. We take an arrow or a lone pair from chlorine and we bond it to aluminum. And now we get this intermediate and since that chlorine is positively charged, then this CCl bond can actually be broken. And if it's broken, then we get this acyl cation plus AlCl4 minus. So this is the acyl cation, which is exactly that one that's required in this electrophilic aromatic substitution reaction. Now, benzene ring then will come, and of course, it reacts with this acyl cation like that, and then we get this electrophilic or carbocation intermediate. And as a result of this slow step, if you recall, that step is always slow, that carbon must carry a positive charge. This carbocation intermediate can quickly regain aromaticity if it loses that hydrogen in the form of a proton to a Lewis base. So that AlCl4 minus therefore comes in, takes off this hydrogen carbon bond is broken, and a new carbon-carbon double bond is formed, and this leads to the product, the Friedel-Crafts acylation product. So this is the acyl cation again that is involved in this reaction as the active electrophilic intermediate, which initiates this electrophilic aromatic substitution reaction. So this is an example of another or an example of electrophilic aromatic substitution. It is an acylation reaction. That's when phenyl ketones or aryl ketones are formed upon reaction of benzene with an acid chloride in the presence of aluminum chloride. It's called Friedel Friedel-Crafts Acylation, because an acyl group gets bonded to benzene ring. So in summary, this is a very useful reaction to make aryl ketones, reaction of benzene with an acid chloride in the presence of aluminum chloride in what is called Friedel-Crafts acylation reaction.